Okay, this I think is problem number 52. It's an example like 51 that you have to do. And I believe when we work through this in the problem set, you work through it two different ways. What we have is the main rule that you have is going to be the power rule. So as we take the derivative, what we are going to do is bring down the exponent, keep what's inside the parentheses the same, and decrease the exponent by 1. Now the final thing that we have to do is we are going to have to do the quotient rule. And the quotient rule is low d high minus high d low all over the square of what's below. So we'll continue on with the derivative. So we're going to have 5, and I'm going to keep this part the same. All right, now we need low. So low happens to be x cubed plus 3. It's the denominator of your fraction. Then we have d high, the derivative of the high. The derivative of 3x minus 2 is just 3. Minus high, which is 3x minus 2. And d low. The derivative of the denominator is just going to be the power rule of the first term, which is 3x squared. Now that is all over the square of what's below. So x cubed plus 3 quantity squared. All right, now we need to go ahead and simplify that. So as we simplify that, we are just going to simplify what's in the brackets. So if we simplify what's in the brackets, I'm going to use the distributive property on that first value, which is going to make it 3x cubed plus 9. I'll use then we have a minus sign. Use the distributive property on the second part, which is going to be 9x cubed minus 6x squared. And then that's all over x cubed plus 3 quantity squared. So now we want to take and distribute that negative sign through. Notice I kept the product of low d high and the product of high d low. I kept those in parentheses because you are subtracting that high d low, and we want to make sure, since that is a quantity, that we do not forget to change both signs. So you're going to have 3x cubed plus 9 minus 9x cubed minus 6x squared. All over, that should be plus 6x squared. All over the quantity x cubed plus 3 squared. So now if I simplify that second part in parentheses, let me slide this up. So we have 5, the quantity 3x minus 2 over x cubed plus 3, all raised to the 4th. And then in your brackets, it's going to simplify. You have 3x cubed minus 9x cubed, so that's negative 6x cubed. Then you have plus 6x squared plus 9 all over, and you have x cubed plus 3 squared again. Okay, so the next thing that I want to do is I want to take this trinomial that I am underlining in green, and I want to factor out a value of 3. So I'm going to factor that value of 3 out, and I'm going to multiply it times the 5. So that's going to give you 15, and I'm going to break this into numerator denominator being raised to that power. So what we have is we have 3x minus 2, and that is raised to the 4th power. And then after I factor out this value of 3, what you are left with is negative 2x cubed plus 2x squared plus 3. And then in the denominator, keep in mind this x plus 3 in this first fraction is being raised to the 4th power, and I have that same quantity here being squared. So you add those exponents together, and you get x cubed plus 3 raised to the 6th power. So that is your first derivative by using the quotient rule. Now some of you, I believe when we first worked through the problem, you chose to solve this type of a problem by taking the original problem, which remember is that quantity 3x minus 2 over x cubed plus 3 to the 5th, and you would write it as two separate fractions, or two separate powers. So you would say it was 3x minus 2 to the 5th over x cubed plus 3 to the 5th. Now from here you could use the quotient rule, low d high minus high d low all over the square of what's below. But when you do that, you're going to have the power rule using the chain rule within that in your simplification. So that's another way you could solve it. Another way is that some of you choose then to move that denominator value up, and you had 3x minus 2 to the 5th and the quantity x cubed plus 3 to the negative 5th. And then from there what you would do is you would do the product rule, 1d2 plus 2d1. So it's up to you. I don't care which method you use, but I'm just going to stick with the first method. Okay, so the final example I'm going to show you, I think this happens to be 54 in the review. What I'm going to show you is refresh your memory on the product rule. So first of all, I am going to rewrite the original problem. I'm going to keep the first factor as the quantity 2x squared plus x plus 1. But the second one, I'm going to get rid of that radical and put it in a more usable format for me, which is to show the square root as the 1/2 power. Now to do the derivative, what we are going to be using is we are going to be using the product rule. The product rule, remember, is 1d2 plus 2 d1. So we're going to go ahead and take the derivative then. 1 happens to be your first factor. So 1 is going to be the quantity 2x squared plus x plus 1. And then you're going to take d2. d2 is going to be the derivative of that second factor, which is going to be the product or the power rule. So we're going to bring down 1/2, keep what's in the parentheses the same, decrease the exponent by 1, and take the derivative of what's inside. So there's 1d2. Then we are going to have plus 2, and 2 is that factor I have underlined in green right there. So it's going to be the quantity of 4x plus 1 to the 1/2. And then we have d1. d1 is going to be the derivative of your first factor, which is going to be 4x plus 1. The derivative of 2x squared, bring down the exponent, decrease it by 1, and the derivative of x is 1. Okay, oh, and I ran out of room there trying to scrunch it in. Alright, so that's what we have so far. Now we want to go ahead and simplify that. So in the process of simplifying, what I am going to do, try to keep these here. I'm going to group this 1/2 and take it times the 4, which is just going to give you a factor of 2. So now I have f prime of x, the first derivative, is going to be 2. And then I'm going to copy down this factor of 2x squared plus x plus 1. And then write what I am left with, which is 4x plus 1 to the negative 1/2 power. Now the second part that I am going to have, I really can't do too much with this except for realize that these are like bases. So when they are like bases, what we are going to do is we are going to add the exponents. So if I add those exponents, all of this second term becomes the quantity 4x plus 1 raised to the 3/2 power. Okay, the next thing that you want to do after that is we have, between the two terms, the purple and the green term, we have this factor of 4x plus 1 that is in common. So remember, if you had something like x cubed and x, you can only factor out an x from both terms. You factor out the smallest power. So here we're going to factor out this negative 1/2. So as I write my derivative, we have 2. No, that's not where I want to put that. Sorry. We're going to have that factor we factor out, which is 4x plus 1. And we want to factor out to the negative 1/2 power. So what we are left with is, in the first term, we are left with a factor of 2 and that quantity 2x squared plus x plus 1. Because remember, we want to subtract what we factor out, so we subtract that negative 1/2. When you subtract the negative, it becomes a positive. Negative 1/2 and 1/2 is 0, so this has a value of 1 now. So it's been factored out. So then if I go to the next one, the next term, we are going to be left with 4x plus 1, and we factored out, so we subtract that negative 1/2 that we factored out, which turns it into a plus, and you are left with 4/2, which is the same thing as 2. Now what we are going to have to do is we are going to have to expand this out by using the FOIL method, or taking a factor times a binomial times itself, and we want to use the distributive property with this term. So the derivative is going to be the quantity 4x plus 1 to the negative 1/2. If I distribute, you get 4x squared plus 2x plus 2. And then if I were to take 4x plus 1 and square it, I'm just going to do it off to the side here, try to fit it in. That's 4x plus 1 times 4x plus 1. So you end up with 16x squared. The outer is 4x and the inner is 4x, so that's going to give you 8x plus 1. Now we just want to group what's in the brackets together. So my first derivative using the product rule is going to be 4x plus 1, that quantity raised to the negative 1/2 power. And then the second, the bracket, we're going to group like terms together. So you have 16x squared and 4x squared to give you 20x squared. Then you have 2x and 8x, which is 10x. And 2 plus 1 is 3. So this is the first derivative using that product rule. So if you have additional questions, let me know. This video is about to end, so I got 15 seconds. Just let me know, give me a message or something, and I can help you.